Hi guys. Uh, Hi Samuel. Hi Martin. Hi Harrison. Hi Magdalene. Thank you guys for joining our session today. This is Azure Group User Group Eldoret, where we do things around Azure. So I'd like first of all to take you through our conduct and what we are. So this is a group that is dedicated to fostering a thriving, respectful, friendly, and professional experience for everyone. Of course, we want to have you feel inclusive or included in our meetups, uh, though we have most of them virtual. We are planning to have some physical. We also welcome and support all members in a safe and inclusive environment where everyone can scale to cloud together. So we are driven by some core principles, that is purpose, feeling inclusive, safe, where there is collaboration and professional growth for all. So we also want you to be very inclusive. As I have said, we welcome all backgrounds, that is genders, ages, races, and religions. We also want you to be very friendly and respectful. So in the professionalism, we want to have you like listening and avoid criticism to other attendees in our event. Like we focus on building bridges, not personal attacks. We also want you to be professional, like no scamming, try to protect privacy and focus on continuous learning. That is who we are as Azure Group Eldoret. Uh, so I'd like to maybe share who our speaker for today is. We have Magda, who is a Microsoft MVP Azure, and he'll be taking us through Azure Storage introduction. So before I introduce her, I'd like to say my name is Charles, and I am a community advocate and a machine learning engineer. So Magda, are you around?
Yes, I am. Thank you.
Oh, sure. Welcome. The floor is yours. Let me stop sharing.
Okay, I
Yeah.
will take over the screen. Just one moment, please. Please let me know when you can see my screen.
Yeah, I can see your screen. Azure Storage
Perfect.
Foundation, right?
I lost, unfortunately, the um, window from Teams. It has happened before. Not sure why, but nevertheless, welcome everyone. Thank you for having me here. I'm really excited to have this session. And thanks a lot for reaching out to me. My name is Magda Wojnarowska-Pietrzak. I've been architecting cloud solutions, cloud and hybrid solutions for over 11 years. And today I would like to share some insights on storage, but often I share insights and observation also via LinkedIn or my blog, Cine.pl. And also, most often, I share knowledge around common cloud mistakes and how to avoid them. And I actually wrote also a book about this. But this time, we'll focus on foundational aspects of cloud storage and what to say about this. So, cloud storage is one of the fundamental building blocks in Azure. So, every application, virtual machine, or solution you build in Azure touches storage in some form. Um, I know that maybe this foundation sounds not very much fancy. However, if you understand the baselines and how mechanism works, you know how to approach it properly, and this topic would be much easier. So let's get to agenda, what I will be talking about. So I will just lay some foundation about what storage is, a bit about storage services overview. I will touch also a topic around redundancy, SLA performance, a bit about tooling. We'll summarize it and then get to the demo. Just one second. Okay. Sorry for this. Oh, yeah, I got back a Teams window. Sorry for this, guys. So if you are talking or we are thinking about storage, think about it as kind of a top level home for your data, kind of a container. So each service within that inside gets its own URL. So for example, for blobs, you have blob, so your name, but blob.core.windows.net. For file shares or queues, tables, it is similarly, as you can see also in the slide. And this is also why the account name, due to the URL, must be globally unique across all Azure. So it literally so the name becomes part of your URL. And Azure Storage is platform as a service, and Microsoft manages hardware availability and redundancy for you. So going to what types of accounts do we have? So there are several types, but most often general purpose V2 is being used. And this supports all services we'll talk about shortly. So blobs, files, queues, tables. And the only reason to pick a special type like blob storage or file storage is when, for example, you need premium SSD performance. And one remark, it's important to note that general purpose V1 will be retiring soon. So right now, probably it is just mostly on some legacy solutions. So going to overview of the storage account services. So one Azure storage account, when we are talking about this, for example, general purpose V2, I can hold all four services simultaneously. So let's walk through what each one means. So first is blob storage, and it stands for binary large objects. And this is Azure Scalable Object Storage and Object Store, and it is designed for unstructured data. So this means files, images, videos, backups, and anything that kind of isn't organized into rows or columns. The second is Azure Files, and it gives you fully managed file shares in the cloud. They are accessible over SMB or NFS protocols. And this you can think of like a network drive. So you mount and it makes it, for example, good for lift and shift scenarios. Third is queue storage. And this is a messaging store used for communication between the different components of an application. So if you have one part of an app that needs a kind of work to do another part to another part asynchronously, this message sits in queue until it is picked up and processed. And the last one is table storage, and this is NoSQL key value store for schemaless structured data. So it's a good fit when you need a fast access to volumes of data that does not require full structure of relational database. So let's dive a bit deeper into Azure Blob Storage. So it's an object store built, as I mentioned previously, for unstructured data. This means images, log files, backups, the data sets that you feed, for example, into machine learning pipelines. So basically, it's if your data doesn't fit into rows, it is the best place. So the hierarchy is simple. So you have an account, which is storage account, then a container, and then blob. So your storage account is kind of a top level namespace. So containers work like folders to organize things, and the blobs themselves are actual files. So there are also three blob types, and picking the right, of course, matters. So there are block blobs, and they are used most of the time. So for general files, as I mentioned, images, backups, and they are built for individual from individual blocks, so you can upload in parallel, which is why they scale so well, quite well, and it is up to roughly 190 terabytes per blob. Then you have append blobs, And the purpose for this is writing the data that only ever grows. So this is like log files or event streams. And the last is page blobs, and they are optimized for random read-write access. And their main job is backing virtual machine disks like VHD files. And with blobs, we have also a tier access. So these are hot, cool, cold, and archive. And fifth one is right now in preview. So it is a smart approach. So this is where it gets smart about costs. So as I mentioned, 5 tier access, and the trade-off across all of them is the same. So pay more to store and retrieve cheaply, or pay less to store, but you need to take into consideration that you pay more to get it back. So the hot tier is for the data which you are accessing, touching daily. So there is no minimum storage duration, but of course the highest cost of storing the data, but of course the cheapest to read. Then we have cool, and this is for things like backups or monthly reports, but you need to take into consideration that there is 30-day minimum stay. So it's cheaper to store, but a bit pricier to access. Then we have cold, and this is for data which you rarely touch, and but you still need to access them instantaneously. But it is minimum 90 days that the data are to be stored there. So it is cheaper for store, but to get this data to read, it's more expensive. And the last bit is from this not in preview is archive, and this is the cheapest to store, but this one is literally offline, so you need to rehydrate the data before reading them. So it can take even up to 15 hours on a standard priority, of course, with high priority much faster to get the data. And the last tier, which is in preview, is a smart tier. So basically Azure watches, monitors the access patterns, and automatically shifts the data between different types of tiers for you. So you do not need to write lifecycle rules. It's actually how it is working. Of course, it is in preview, and it is being moved to general availability in some regions. And two things to also worth to note. So there is this lifecycle management, and Smart Tier is taking care of this for you. But for other, you are able to write your own rules when to move which data and how. And the second set is steering it on individual level of blob. So uh, in a nutshell, about blob access tier. So it is all about understanding how you will fetch your data, how you will need them, or basically use a smart preview to help you adjusting. The next type, we have Azure Files. So it is essentially cloud-based network file share. So you can think of it as an NAS. And instead of, for example, buying a physical device and managing it yourself, you can create a file share in Azure and mount it directly from Windows, Linux, or macOS. And there are two protocols that are being offered. And this is the detail that is worth remembering. So you have SMB protocol, and you have NFS protocol. But one rule to remember is that a single share can't do both. So you have to pick before creating them. And this is this important bit. You cannot do two in parallel. And for caching, you have Azure File Sync that helps you keep local fast copy on premises, while the source of truth stays in the cloud. So it is kind of good solution for hybrid setup. And a use case you can think is for example, go to for lift and shift and on-premise file server for sharing a config files or tools across multiple VMs or dev teams, or for example, for Kubernetes persistent shared storage volumes. And the last two types that I mentioned at the beginning are queue storage, which solve architecture problem for when two components need to talk one to another, but you don't need to tightly couple them. So one component drop a message in the queue and another picks them up from the queue whenever it's ready. And also worth to know that the message is max at 64 kilobytes, and also the default time to live is 7 days. And another is table storage, and it is a cheap and fast NoSQL store. And you can think of it like a spreadsheet where every row can have a different column, so no fixed schema, and each entity can be up to 1 MB. So it's very good for things like sessions, devices, telemetry, or event logs, or lookup tables. So let's get to a bit about redundancy. So lots of things which are kind of related to the storage aspect, so lots of bits of things. So Azure always stores multiple copies. So we have a different redundancy options, starting from a primary region where we have local redundancy. And this keeps 3 copies, but in the same data center. So it's cheap, but if disaster occurs for the whole kind of set of buildings, it burns down. Or in case any other kind of climate disaster or issues. With zone redundancy option, it spreads across 3 physical availability zones within region. So it's still within region, but different physical locations. So in case one data center is down, still you are fine because the data are being spread. However, if you are moving to prevent some issues within the region, you have globally redundant storage, or so this takes further and replicates your data to the second region. So 3 copies in primary region and 3 copies in secondary. And you have also GZRS, so zone with zone redundancy included, and this does the same, but it combines also the zone redundancy. With array prefix, it is a read access, so this is the detail that is also quite often missed. So you get, of course, this global redundancy or global zone redundancy, so the second copy sits there, but you can read it after failover. So this is what this read access stands for. So also, just as I mentioned in a nutshell. So then we can get to SLA. So one caveat worth keeping in mind is durability. What durability is about? It's about not losing the underlying data across both replicas. So these 9s we just were just in the slide with, for example, RS and ZRS. So it's not the same with availability. So when we talk about availability, it's whether the service is up and reachable. So a region outage can make your data temporarily unreachable without, for example, actually destroying this. And this is a separate SLA number from the durability trigger. So availability is it's whether you can actually reach your data right now. And that's why that's what SLA describes. So if we look at 99.9%, availability, it sounds good, but in a scale of a year, this is kind of more or less 9 hours of potential downtime. So for production storage, it may be too much. So you may, for example, try to achieve this or reach for this 99.99%, which gets under an hour a year. So basically, yeah, this is worth to consider to differentiate between actually availability and durability when you are selecting and then calculating for your solutions. And at the beginning, also, I mentioned standard and premium. So when you create storage account, one of the choices you need to make is whether it is whether you're striving for standard or premium performance. And this applies to the whole storage account, so not only individual services. And the standard is backed by HDD hardware, and the latency is a millisecond range, but that's perfectly fine for vast majority of workloads, file shares, backups, this general purpose storage. But premium is backed up by SSD, so you have a sub-millisecond latency, but of course it costs more. So if you want, for example, for databases or AI or ML workloads or anything, powering an interactive app where users are, for example, waiting on response, it's worth considering premium. And one thing to remember is when you select this premium or standard, when you're creating a storage account, you cannot change it after creation. So when you pick wrong, you cannot flip it back. You have to recreate the entire storage account. So in case you had their data, you have to copy them. So it's really worth remembering this part. So to get quickly to the tooling, so I would cover here with the basics two tools. So one is Azure Explorer, which is free desktop GUI for Windows and macOS and Linux. So basically, you can think of it like a Windows Explorer, but for storage account. And you can browse containers, upload or download files manually, manage access tiers, or create snapshot, and of course, troubleshooting what's sitting in your container. And if you don't want to install, for example, this tool, you can also have the same experience in Azure Portal, which you will see a bit later during our demo. So there is a storage browser tab within a storage account. And the second is AZ Copy, and it is a command line equivalent. So it is fast cross-platform solution that supports transfers if you are uploading. For example, if your large upload is interrupted, it can pick up where it was left off. So when you need to migrate a large amount of data, Azure Copy is the right tool. So in a nutshell. And when we are about migrating large amount of data, it's worth mentioning also Azure Data Box. So it is the solution that solves the problem with very large data sets, or also when you have not really great internet bandwidth. So basically, say you need to go with 50 terabytes of data on one GPS line. So it's kind of a few days of transfer. So ignoring some interruptions, etc. And with Databox, Microsoft ships you a physical device and you copy your data over, which is much faster locally, and then you ship it back for the upload to your storage account. So as you can see, there are kind of a few options depending on what type of migration, what scale of migration you are, and of course, what amount of data basically you have. So just worth noting this. And the last bit, because also at the beginning I mentioned the virtual machines, so it's worth to mention also managed disks. So it's not under the storage account, so you are not managing it, but every Azure virtual machine has storage attached to them in the form of managed disks. And the key here is of course managed. So Azure actually handles the underlying storage account for you. You do not need to create it separately as it is for blobs. To apply it for disks. Disks are being handled. You just select the disk type and size, and you do not need to provision and manage storage account yourself. And there are different tiers, and it's really kind of performance versus cost curve. At the top, of course, you have Ultra Disk with the highest IOPS and sub-millisecond latency for kind of mission critical databases like SAP HANA. And then you have also SSD V2, uh, which gives you high independent adjustable IOPS and throughput. So it's also great for databases and high performance apps. And you have SSD, so premium SSD, which is also kind of quite standard choice for many production workloads, so solid, predictable. And you have a standard SSD as well, which is a bit step down, but yeah, more economical and also kind of good fit for many solutions. You have also kind of standard HDD for more or less the backup currently. So yeah, just in a nutshell about the disk. So what is also worth knowing beyond, of course, storage count. So it's not a foundation, but still worth to be having. So managed disks I've already covered previously. There is also Azure Elasticsearch when we talk about storage in general. It is a fully managed storage area network in the cloud, great for databases, VDIs, and also the solutions that need high IOPS across multiple compute resources. You have also Azure Container Storage for Kubernetes persistent volumes, and you do not need to manage the underlying storage yourself. You have Azure NetApp Files. It is with a partnership with NetApp for high performance NFS and SMB, commonly used for also SAP and Oracle workloads that needs kind of enterprise grade file performance. And Azure Luster, the purpose for HPC and AI, so extremely high throughput for really massive parallel workloads. And the last bit, which is also still in preview, it is file shares under Microsoft file shares. And this lets you deploy an NFS share as its own top-level resource, so without needing a full storage account wrapped around this. So another file storage solution. So it is in a nutshell about foundations. So a quick recap before we move further. So a storage account, you can think of it like a container. It gives you unique namespace, and general purpose V2 is kind of a default choice for majority of, maybe not majority, but really lots of solutions. Inside you get 4 services, each for different type of data and designations. So Blob for unstructured files, for SMB and NFS network shares, queue for messaging between components, and table for simple NoSQL. You have, of course, managed disks, which are a bit different, and this is how VMs get their storage, and it lives outside your managed storage account. So it is basically being managed for you. And worth to know with the blobs that you have access tiers for access tiers. So hot, cool, cold, and archive. And the fifth is this smart, but still in preview. And worth to know remember also about redundancy and different separated solution, how it controls where copies of your data is being stored, and of course availability, so how quickly the data can be, or basically what's your SLA. And the last bit is performance tier, so standard versus premium. So it is a permanent decision at creation, so um, yeah, be careful before selecting one and later on upload your data. So it is in a nutshell. So we can maybe switch to demo. So here we'll be applying two simple solutions regarding creating a storage account, one with CLI and one with Portal GUI. And we'll just create one Blob account and move data basically via storage browser. So you will see how it works. And later on, we will basically clean the environment. So let's go to the portal. Can you see my portal screen? I hope so.
Yes, yes, it's visible.
Yes,
Okay,
yes.
perfect. So let's first create a resource group. And you know how it is when you are just doing the demo, it doesn't want to load so fast as you wish, but nevertheless, storage, for example. Okay, so review and create. Okay, so resource is being created. I will refresh it. And in parallel, we can also create resource group with CLI. So basically how you are getting to CLI, here you have Cloud Shell, and it is already pre-built with all the necessary commands you may need. So basically you can also paste here. I have commands already prepared. So for creating a resource group, and it's basically being created. So right now we just need to refresh and wait. So this which I created manually, it's already in there. So I created already here the storage, sorry, a resource group, and we can start creating the storage. So basically, when you go to the resource group, you are then creating plus create. Of course, there are many ways for doing it, but yeah, I selected my resource group in which I want to create the storage account. So basically, you are just placing here storage account, typing here storage account, you are selecting, basically create. And of course, you need to be careful which subscription in case you have more. You're selecting which resource group. So I'm selecting this one, but of course I have three other, but for this one, I'm creating my storage account. As I mentioned, storage account name should be unique. So basically, in case for example, test purposes, I'm trying to, it will be kind of GUI. So I'm trying to just get with, for example, date, month, day, and for more or less the time. So yeah, it is more or less unique then. Just preferred storage type. As I mentioned, here's this performance I was mentioning about. So between standard and premium, I'm going for general purpose V2 standard. And here is this redundancy option I also mentioned. So I'm selecting locally redundant. So as I mentioned, this is the cheapest one, but for the purpose of a test, we do not need to strive for higher. Then you have some advanced options regarding, for example, blobs, which type, access tier. So it is what we discussed. Here is not this archive. As I mentioned, this requires later on rehydration and for life cycle purpose part. Of course, networking will be doing enable from all networks, so it is easier for move around, but so having this kind of public access, but not it's not kind of recommended for any data and generally outside the tests. I do not recommend public access unless really you need the data to be exposed in this way. Then data protection. Of course, you have options for soft deletes, so that you are not able to delete directly the data and they are being retained for several days, just in case accidental deletion will come into picture. But I'm just unchecking this. because yeah, it's just for the test purpose, so that's why. But basically, this may be needed. However, even though you uncheck it, you can still have a policy which is being applied for the whole environment, which can extend this period to have a soft delete in place. So then security, I'm not changing here anything. We have also encryption tab, but I'm using Microsoft Managed Keys. So basically review and create. So let's see how this will work. Okay, so it's running. We have storage account. So let's go to the CLI. We have already the subscription. Subscription and resource group. So right now about creating the storage account with Azure CLI. So basically we are having storage account, create, this is a command, then minus name, so minus n. So as I mentioned, I was just selecting the name. Then minus G, it's a resource group. And this is a second resource group, but it was created already. Then minus L, so it is the location. Then SKU, I'm selecting a standard LRS, so local redundant storage. And storage V2, so this is this general V2 purpose. So enter. So it will be in progress. And let's go here to the storage so I can show you a bit about browsing. So this is the storage browser tool. You can, of course, install it locally, but you can use it directly in Azure portal. So it comes handy because you are able to view what storage containers you have already. So we have just created a storage account, so there is nothing in there. And as I mentioned, you have this 4 types, so blob containers, file shares, queues, and tables. So for this purpose, we'll be going with with a blob, and I need to add container first, because if it is not added, you cannot just upload the data. You need to have a container that will store your files. So let's go with test container. And the second has been created. Perfect. So I created the test container, I select it, and then we will do the upload. For this purpose, I have already the test file. So drag and drop the data. So the file is being uploaded. So you can, of course, edit in here, test, save, and you have your data. You can, of course, download the file later on. So for this purpose, you are able to download, no problem. So, but of course, it is about how we created this storage. So it was here in networking, where I mentioned, this public access that is enabled from all networks. So, but of course, when I will go in here, I can change to disable, and then I won't be able to access the storage account without, for example, a setting, kind of private network, etc. So for my purpose, it's the solution I want to choose. I will go to the resource group. Okay, probably subscription would be the best. Okay, so it was how to create it manually and how to upload the data. Here is, of course, resource group 4, and this is the storage account I created with CLI. So as you see, programmatically, it's also with the command lines, it's also how it can be done. Of course, it's not described with a code, so it's just for by code I mean like Terraform, that it's kind of creating everything from the scratch. So it's just simple command how you are able to do this in the same manner as you are just clicking via portal. So much faster, just providing here the command. And of course, storage browser here is also available. I haven't created any container, so I can create this manually as well, or even with a code. One thing though, to remember when we are in the subscription. In case you will get an error when creating, so we have new subscription and you need to create a storage and some errors are being thrown, always check if you have enabled a resource provider, because in case you do not have a resource provider for storage registered, it won't allow you to create a storage account. So just important bit to bear in mind. This is not only for storage. Other services have also this registration required, but it's really worth to bear this in mind. So we have here the subscriptions. So it's always, oh, I mentioned also that we will create, so I will create here quick storage, just quick container. So we'll move the file also with the code. I forgot about this bit. So let me add container. Let me check if I have found. No. Okay, so it is in there. So let's upload. And let's see if it is uploaded. Yep, here it is. So we have our empty, just created test data. So basically, this is almost it. So in case you are doing the tests and in Azure, in the cloud generally, every minute counts. So you are basically paying per minute. It's worth to clean up after you are done with your tests, not just leaving it out there, because it can cost you for just a storage account. It when you are not storing any data, it's not generating the cost. However, it's worth to keep this, or just keep in mind how to clean up environment, etc., because it's a habit which later on pays off. So we can delete entire group. So for this lab 4, we created programmatically. So I will just click this. And for this, how to do it in a portal, basically, you're just going to a portal and you can click here, delete resource group. So basically you need a resource name. Always this is mentioning in case you are just removing more, it's just asking you, for example, to either confirm, provide a name, etc. So just read the not this one, this one. Okay, so this is being deleted right now. So basically it may take a moment. The same in here. So sometimes refresh take a bit, but it's basically this. So just getting back maybe to the rest of presentation. So I have also prepared a few reading materials that are worth to maybe dive a bit more into. We'll just get back maybe in a second if this is deleted already. Okay, one has deleted, so this which we deleted programmatically, as you can see here, progress bar, it's still running, so this storage account is being removed, but this one which we did from the CLI, it's already in there, ready, done, removed. So the last bit is quickly catching up. So yeah, basically almost there. That's it. So thank you very much for being here. I hope it was interesting for you. You learned something, and yeah, it was nice use of this evening. I see question.
Hello, how are you?
Hello, I'm fine. How are you?
I'm good. So I just wanted uh, a small question on provisioned V2 file shares. There is this meter called it's on chat SSD LRS overflow snapshot usage. So the experience I had, which was very nasty, was that I provisioned a premium provisioned V2 file share, and at 1.5 terabytes. But when I backed it up, somehow behind the scenes, I was getting charged for excess snapshot usage, and I didn't understand why, because it had come to up to 36 terabytes. So basically, Microsoft, when I did a backup, stored the backup within the share itself. So I wonder how that practice is, and why that architecture is that way.
I haven't experienced this particular problem, but I think I read about this on Microsoft Learn questions about being charged for some snapshots. I cannot recall this directly, so I do not want to point you in the wrong direction, but I believe I read about these snapshot issues, and I remember someone responding, so I cannot directly mention how this architecture works. I will need to also check this, but I remember someone else experiencing the same issue as you did. So probably there will be some information.
Yeah. Okay. It's really quite interesting and confusing, because what actually happened is that I when I provisioned a file share at 1.5 terabytes provisioned file share V2, I expect that I'm being charged for 1.5 terabytes. But when I backed it up, then Microsoft, instead of doing the backup in the recovery services vault or on a backup vault, what happened is that they did the backup within the same share that I'm backing it up. So two things happened there. One, I didn't have a real backup because the backup is happening within the share that I'm backing it up. And two, I'm being charged for the storage that I have not provisioned, because I provisioned only 1.5 TB for the actual real storage that I'm using. But even the backups that is within the share, I'm getting charged for it. And the meter is the one that I have shown you on chat. That's
I do not have access to chat, so yeah,
oh,
I'm
sorry.
just no
Okay.
apologies needed. Chat is not available because I'm due to I'm probably outside organization. But yeah, the topic is really interesting. As I mentioned, I haven't experienced this particular case, but I remember really that it crossed some or point was pointed to my attention when I was just reading some issues on storage account recently, but not personally experienced this problem that being charged kind of double with having one the backup somewhere else. But really, I will search for it because it's really it can be really kind of problematic, especially in regards to costs. This is 1.5 terabytes you are being charged
Yeah,
additionally.
cost. one cost, two, it's not a real backup because because the backup is
Oh,
within
yeah,
the share. So in case something happens to the share, you don't have a real backup somewhere.
exactly. Another problem. Exactly. I totally agree with you. Apologies for not being
No, no
not being
worries.
able to provide more information, but due to no personal experience with this particular aspect, I can't relate directly, and I do not want really to steer you in the wrong direction or try to devise something right now. Uh, so not being able to help here at this point.
No, thanks.
Thank you for sharing. It's really interesting topic. Okay, and yeah, this is removed. So at least this part is done. So yeah, I see no further question. Thank you very much for taking your time this
Oh
evening.
no, excuse me.
Oh, you
Magda.
have.
Yeah, I have one. So, like with the many, what do you call them? With the many storage options in Azure, that is Blob, File, Queue, Table, how do you decide which one to use for a real world project? And can you walk us through like your decision process? How would you do it?
So basically, what I'm selecting, it depends what type of data or what type of designation it is. So as it was also at the beginning, it really depends what type of information you're trying to store. So recently, I was working with one of a project where basically we were using import files. These were CSV files, and each of these were separate. So we had automation scripts, which later on were taking the information which were in CSV files and applying them to our system. So we were just fetching proper kind of columns, etc., and different people were uploading the files to the Blob storage account. So we selected basically Blob because this data were just separate files. So the files were structured, were having structure inside, but basically we just needed a simple solution for storing the files. So you are just approaching it on per case basis, and we used standard. So maybe going to what type we used hot storage count because it needed to be accessible. Later on, we had a policy for removing the files after some time because they were not needed. So basically, after uploading, we really haven't checked the files after all, so we were moving it to a separate blob and later on with a policy removing. And we used LRS also, so locally redundant storage, because for this particular project, we do not need to take care about backing it up because once the data are fetched from the storage account, so in this case it was blob, later on we didn't need to use them at all. And if they will be lost, they were still being moved to the database of the system. So these data were kind of backed up with our database. So the, for example, sole purpose for this storage account, it was just for uploading the data to our system. So it's just one of the example how I'm approaching it. So what is the purpose of a project? How you what type of data basic you are bringing? So whether it is just images or structured data or for the queues purpose, what types you also need, because whether you have a table, you have also Cosmos DB as another solution, or Q, you have Service Bus, which is enterprise grade. So you are just selecting which solution is best fit for the case you are having, and of course, related to the costs as well. And additionally, the all aspects you are later on verifying when designing is to understanding your needs and how these needs are later on reflected in the infrastructure and cloud infrastructure in this meaning, and the solution itself, and how to bring these pieces of puzzle all together. So the same is also about location. By location, I mean here I selected, for example, West Europe. This is the location near me, and it's kind of a best fit, but it also ties to the data in case you need to have a data due to a certain restrictions you are in, and this data either needs to be kind of in the location near you or are bound to certain restrictions and cannot be moved from a certain location, for example. So different aspects, but as I mentioned, I try to understand the needs, the requirements, the conditions I'm bound to, and then select the best solutions or the most efficient from the implementation perspective for my solution and from the costs. Does this answer your question, Maury?
Yeah, it's answered. So thank you.
Thank you.
Masharia, Samuel, you have a question?
Yes, I do have a question. So I noticed that Magda, you mentioned that we are now moving from general purpose V1 in Azure Storage to general purpose V2. So it's basically outdated. So I was just curious, how can attendees stay updated in terms of knowing what's new with regard to Azure? Are there particular blogs or sites that they can subscribe to?
So I'm really maybe not subscribing, but following Azure status. So basically, you are able to get the status. So many updates are being shared on a regular basis. And personally, I also follow John Saville because he is doing on regular basis the videos where he's sharing lots of in-depth details about what is happening, how things working, etc. certain way, and also providing the updates. So of course, I'm reading what is happening in Azure. I'm working with it, so lots of information are also coming and from my experience. But I really recommend John Saville and Azure status updates to subscribe to.
Thank you for that.
Thank you.
Okay, I guess we are done with questions, right?
I do not see any other hands up, and I see that a few participants has already left. So probably no further questions at this point.
Oh, sure. Magda, thank you for attending our sessions and giving us an insightful sessions on Azure Storage. We really appreciate for you taking your time and having us as your attendees. Yeah,
Oh, thank you very much for the invitation. It's been a pleasure, and yeah, hope to see you soon, guys. Thank you very much.
for sure. So for the attendees, I guess we will upload the content that has been shared and we'll share it via our YouTube channel. So whenever you see the link, subscribe to our YouTube channel and like the videos, comment, share to your fellow colleagues. Let them learn from whatever we share. Yeah, thank you also for the attendees who attended the session. We look forward to having you in our next online webinar. Yeah.
Thank you.
Have a good night, guys.
Have a great evening. Bye.
Bye.